Cool.
Okay.
So today we'll be talking about promises, API, fetches, and JSON.
Promises.
He's taking care of a few things.
So we're starting to figure out what the impact is.
Yeah, so we're gonna figure out what these words mean and what the hell is going on here. So I know we want to work on our code words and HackerRanks a little bit, so let's close our laptops unless you're taking notes. Chris and Dan.
I'm submitting final.
Okay.
It's on the
So-
other side.
What?
It's on the other side.
Yeah, all right. So here we are, promise APIs, fetches, and JSON. So our current problem, our current predicament, is that we are working completely 100% local. So if we are, so that means that if we want any sort of data or logic or anything like that going on, we need to input it ourselves. We need to code it ourselves. If we wanted to build like that color picker we did last week, that random color generator, we had to build that ourselves. If we wanted to get a list of all of everybody inside the company, we have to put it in ourselves, right? It's all very manual. Well, fortunately, there's a big wide world of programs, algorithms, and data out there for us already. That's where APIs come. So APIs stands for Application Programming Interface. And at its highest level, at its most generic level, it is when you have two programs talking to each other, they talk through APIs. So we've actually already used APIs before. You know math.ceiling, math.floor? Well, at that point, we're using the math API. That's not on a different server, but that's someone else's code. So whenever we type math.ceiling, we're not writing the code to truncate a number. Someone did that for us.
So it's like a function, a built-in function?
It's a function that you didn't write.
Okay.
It's just someone else's code, and it's my code using your code. So that's the highest level. A good example of that is math.ceiling. But in the general sense, in the sense of the web, APIs are usually web servers hosted on someone else's machine or somewhere up in the cloud. And we are using our JavaScript or our server to hit their API to do something or to get data of some sort. So it's taking that concept of math.round, and instead of that logic happening on your local machine, that logic is happening someplace else and then returning to you some result. Same thing, it's just a function, except a function not being run on your machine because you can write it.
Let's say my whole website is a picture, and instead of having the picture locally or whatever, I'll just put a reference to the picture that's somewhere.
Yes.
Bring it here, put it there.
Yep. So if you don't want to host pictures on your website, there's a picture sharing site right out there that I'm sure we're all thinking of, Imager, Flickr, or something like that. We can put our image up on there, use Imager's API to pull in the picture and display the picture for me.
Is that the same thing as requesting a service or requesting a service from a different system?
Yep. Okay, that's it. Feeling good so far? So, what's next? Haha. So we do this using HTTP requests. So remember day one, way back when, we talked about what an HTTP request is? So what's an HTTP request?
It's a call to the machine, the remote machine?
Yep, it's a call to the remote machine. It has a verb traditionally attached to it. We've only talked about get, right? There's also post, put, and delete. We're not worrying about those yet. We're just getting data. It's going out to a remote machine. It has a URL attached to it, some unique identifier. For the longest time, we've been doing this localhost 3000, right? It's just one page. But if there's multiple pages, each URL is unique. And also, HTTP requests have a status code, right? So it's some 3-digit number that says whether the request was okay or not okay. I'm sure you all have encountered 404s before. I'm trying to work with images or resources like, oh, 404, what? We know that 200 is the good resource for that. What else? We know that requests have a header, right? That have a whole bunch of metadata about it. We haven't dug into what that metadata is yet, but we know it's there.
Is there just one call to send and then one to receive, or is it on
That's part of it. There's a sending and then there's a receiving part. Yeah.
You're gonna answer and then you.
Yeah, like we're almost there, but you're in the right. But you're on the right track. Also, the request, the response that you get back from it has the body, has the actual data. So far, all of our data has been HTML, right? The request we're getting from our web server has been our own web page. Well, here we actually use something that's called JSON. So JSON, have we touched on JSON yet? So JSON is an acronym. What does it stand for? Any guesses?
JavaScript.
Notation, JavaScript, object notation.
Yeah, JavaScript object notation. So, yeah, right. So all this is a human and machine readable format in how we exchange data. This has kind of become a standard to how to exchange data via an API. We do it because machines can read that and humans can read that. So it looks like a JavaScript object, right? We have, it is a JavaScript object. It's in the name. It's just a series of key value pairs. There's that word again, key value pairs. So we have the key over here and the value over here, just like an object. Values can be of any types: arrays, objects, booleans, numbers, strings, and everything. And on the front. So whenever we make our request out to that unique URL, that remote server, we're going to be getting back JSON. And then we, as developers, take that JSON and we'll parse out, we'll take what we want and put that into our DOM or do some logic with it, or do something with it. Make sense so far? So instead of us having to hand code this and type this up ourselves, we're saying, hey, API, give me information on Luke Skywalker so I can display that on my page.
So we go to the Star Wars API and that's where it.
Yep, so Star Wars API is what we're going to be working with today. It exists just for this reason. It's actually,
it exists?
Yeah, that's actually pretty cool. We're going to build a Star Wars API Explorer later today.
Good.
Yeah, right? How do we do this, right? The idea sounds awesome and nice and sweet and simple. We're going to be using something called fetch to go get our data. Isn't it so fetch? That is like my favorite joke to make ever. Because I'm going to make fetch happen, I swear. So fetch is a relatively newer way to do JSON or API requests with JavaScript. There's another way to do it. It's like it's XML HTTP request object. A few of you might have seen that before. That's the old way to do it. This is the new and improved and better way to do it.
Does it still do that in the background?
Yeah, this is just a nice, pleasant wrapper for that.
What's the difference between get and fetch?
Fetch is the JavaScript API that we'll be using to make the request. Get is the HTTP verb that the request has.
So fetch can have get. Fetch can have post.
Fetch makes get requests.
Okay. I'm sorry, so fetch is a JavaScript API.
Yep.
Get is a HTTP
Verb.
protocol.
Yep.
Protocol, whichever.
Are we talking about Git?
Not
Okay.
get G-I-T, get G-E-T.
Okay.
Actual
Get,
get.
yeah.
Real world get, not our get. So, fetch, in order for us to use fetch, we have to learn a new concept real fast. We're not going to dive too deep into it, we're just going to understand it on a surface level. And that concept is promises. So what promises do? Promises help us handle long-running requests. So what do I mean by long-running requests? So up until now, our functions have been fast, right? They're not really doing much. They're interacting with the DOM, maybe adding a few things, doing a couple for loops, all locally, all in like almost a set time, right? Like we know how long it's going to run. So it's not a long run request. Whenever we make a request out to a remote server, we don't know how long that's going to take. There's so many things going on there. There's what's our network speed connection going out to it? How long is the actual request going to take to fulfill? What's the network speed coming back? So we don't know. So that's considered a long running function response or a long running function. So we just don't know. And that's hard to code around that because we don't know when we can execute the next line of code, right? If I want to go A, B, C, D, D to execute all those functions, if I rely on something that comes back from one of those responses, then I don't know when it's going to come back. So I need some sort of management tool, some sort of API, some sort of something in my tool belt to help manage that control flow. And that's where promises come in. So at its core, this is a simple fetch. I'm saying, hey fetch, go to this URL, make me a GET request on that server, and then .then, that's the promise syntax coming in. Whenever that request is done, then run this code in here. I'm saying, make the response, then run this code.
So the response after the then is a reference to the whatever came back?
Yep.
And then you just print it out. Okay.
Yeah, so that response, that resp, so then takes a function that has one parameter, and that's the response from the server. Now that response is everything. That's the metadata about the response, that's the actual data itself. We'll see later that's a whole bunch of stuff. Status code, error messages, the body, everything like that. So it's going to execute in an asynchronous manner.
Is that done in its own
So there's like 3 questions, at least one of them. V, Daniel, then Gus.
So the fetch happens in its own thread in the background.
Nope, not in its own thread in the background. It fires it off, and then it waits. Other code can still run.
So you still have a response from your web page.
Yep.
So it's in the background?
Sort of, yes. I'm going to say yes. We're going to explore that on Thursday.
Okay.
Daniel?
What if you're debugging and you just want the error code back? Specifically, you want everything else, at least at that moment,
So you plan for the error code?
Yeah.
What you can do with that is that after the response comes back, you can do like response.status code equals whatever you want.
Okay.
Yeah, you can change the response thing in.
So basically, it will display in the log. I mean, I'm guessing the sixth person of that API is Luke.
It's not, but it's
It's not okay, but it will display that person
Yes,
on the log.
on the log. It'll display all the metadata, so its response code, its status, where it came from, stuff like that, as well as the data itself. So it's going to do everything.
And that response is in a JSON format.
Can you describe asynchronous?
Yeah, so asynchronous, that's a very good question. Asynchronous means that it's happening, you have multiple things happening at one time. So that's versus synchronous. So we've been writing our code pretty much in a synchronous fashion. One chunk of code is running after the next chunk of code, right? Well, now this asynchronous code, it's possible to have 2 different functions running at the same time. Because what's going to happen, and we'll explore more of this later, once this fetch gets called, it's going to call off, then it's going to continue executing code down here. And then once that call gets back, it's going to jump up here and run this code up here. So now our code is in even less of a sequential order than it was before.
Even less.
Even less. And that's okay. It's nothing to be scared of. It's just now we can have multiple things running at the same time. And it's something for us to be aware of. We shouldn't really hit any big issues with it yet. As long as we maintain our scope rules and know what variables we're using and see what's going on. But yeah, does that answer?
Yeah.
Feeling okay with this? More okay than not okay? Sort of. So let's see another example. So this is a more complete example. Got to really expand your minds. Here, what? Yeah, so I'm making a fetch to get the 6th person in the API. And then one that's back, I want to look at the response. And if the response code equals 200, I want to actually then return another promise, which is parsing the JSON object, the JSON response, into something that I can use. If the error code is not 200, so if it's an error, so if something went wrong, I want to display an error message. Right? But if it's okay, then I'm going to return this rest.json returns a promise. So now we're going to jump down to the next .then, and here's where I'll actually have the data itself. Question?
Is the JSON in the last .then? Is that semantics? You can put anything.
I
you
can put
want,
anything. I can put
but it's
data.
just
I
to
can
help
put
you
loop.
know what-
I can put Uncle Ben. Yep.
just to help you know what comes back.
Yep.
But the first JSON refers to the second JSON.
Right here.
Yeah.
Yeah. This return rest.json now kicks us down to here.
Okay.
Yep. Because this returns a promise, and in order for us to fulfill that promise and to act after that promise is fulfilled, we need to call it .then. Chris.
Well, I was just wondering. So in the first, when you're fetching,
Yep.
and you're waiting for a response.
Mm-hmm.
When you're waiting, as soon as it comes back, you're doing the .then.
Yep.
Is it doing the same exact thing for the rest.json? Is it
So-
requesting something, and then once you get a response, then you do the .then again?
It's not requesting something. That .json is converting whatever that response is from that raw HTTP response into a JSON object. That itself is a long-running task because we don't know how long it's going to take to parse it.
Okay.
We're just saying, and when I say parse, that's converting it from the raw data, the ones and zeros and bytes that it's coming, and converting it into a JSON object, something we can actually process and use.
Because obviously, when you request and respond something, it can only be machine code, like packets.
Yeah. Yep. Yes.
What does 200 stands for?
200 is the OK status.
That's the cement.
400 is the bad.
Yeah, so 200 is good. Any sort of brand of 200 is usually pretty good. 400, there's 400, 401, 404. 401 is unauthorized. 404 is not found. 300s are redirects, meaning your request is going someplace else.
So an happy sends you to another happy.
Yeah.
Sorry.
500 and something is a bad error. That means that the server crashed. Yeah, so like 501, 503, 505.
Can't find the server.
My favorite one is 418. It's I'm a teapot.
Really?
No joke. Status code 418. I'm a teapot. My favorite one ever.
What does it mean?
Is that like an insider programmer joke?
No, it was set up so the people who manage the status codes. So April Fools is like my least favorite holiday because the tech community goes crazy for it and releases a whole bunch of like really wacky products. And as a joke, the board that manages the status code, like the internet people, the people who run the internet, they're like, yeah, let's make a status code called that returns I'm a teapot. And we're like, okay, why not? It's a April Fool's joke that's gone awry.
But it doesn't mean anything.
No, it's just fun.
Just returns that when it keeps going.
So that's the complete example. This is what your code is going to look like tonight. This should be very similar to what you should be expecting. We're using a few new words here. We have a prompt to take a picture. And if someone reminds me, I'll even blast off the slides.
Or am I?
Okay, someone does. I want to get in that habit of sending out my slides every day. I think that'd be helpful. Anyways, so yeah, that's how we feel with that.
Just a quick question. Yeah, I noticed that the function the way that the function is defined is sort of different than the way we've been defining functions.
Still an arrow function.
It's still,
You could put parentheses there. I think it's just an arrow function. That's all.
If there's only one parameter, you don't have to put parentheses.
Yeah, parentheses are optional for one parameter functions.
okay.
So I'm asking for a piece of data.
Yep.
The 6th birth of data, whatever it is.
Yep.
Then I'm waiting for making sure the response status is good.
Yep.
No error or nothing.
Yep.
If it's bad, display our message. If it's good, return the response, the JSON per se, the data, all the data.
Yep, perfect.
And then I'm gonna display the data in a way I can read it.
Yep. Spot on. So, as with using any sort of API in code that's not ours, we need some sort of documentation. Like, how does it work? I didn't write the Star Wars API. I don't know how it works, so I need to know how to use it. So let's go in and read some documentation and kind of see what that means. Swappy, yeah. So it's swappy.co. It actually is a Star Wars API. It's free, open, there's no authentication, we've done none of that stuff. That's a whole nother topic.
Yep.
So, but here we have documentation. As we can see, it's pretty long. There's a lot here. Rule number 1, don't panic. Rule number 2, you don't have to read all of it. That's the kicker. Usually they have some sort of getting started or like how to or where to start or start here. So we're going to start there. And hey, getting started, how about that? So typically the best APIs will have, hey, what does our URL look like? What's a sample URL? And then what does the sample response look like? So here we're saying, hey, we're using HTTP. We're giving you back JSON. And here's a sample structure right here. So that's good to kind of see what you're expecting to get back.
So when you get back to JSON, it's going to look exactly in that structure.
Yeah.
So I can just open it up as a text editor and say, okay.
Mm-hmm. Like this is what I should be expecting. I should be expecting something that looks like this.
Where's fetch?
So this, great question. Where is fetch in all of this? Fetch is unique to JavaScript. If we're doing this with C#, we're going to use the something called REST to make the request. If we're in Ruby, we're going to make whatever Ruby uses to make a request. Whatever library you use to make a request is unique for that language. So you won't see any mention of JavaScript in here at all. This is all just HTTP.
So the fetch would be where HTTP is if we're getting started. Like,
No.
That's the return.
Yeah, this is the return stuff.
no, above that.
Right here? Yeah, so you'd plop this into your fetch.
Nothing separating the P with the S there, just empty space.
Nothing but you would need to. So let's say that I want to just get one person. So I'm going to get what endpoints I have. I'm going to get what parameters I have. I'm going to get an example request and an example response. So there's a couple of words that we haven't talked about yet, right? Let's rewind this a little bit. So the first one I said was endpoints. What is an endpoint? An endpoint is just a function that's available for us to call. That's based off of a URL. So if I wanted to get a person, I have 3 different endpoints that I could use. So /people gets me all the people resources. /people/ID, whatever ID I pass it. So it was 6 in my example. I can pass it an ID that gives me that specific person. Or I get the schema, so view the actual structure of what I'm getting back. It gives me an example request. So like, hey, what does this look like? Whenever I call it, what does my fetch parameter take? And then what am I going to get back? So I can test this completely inside of the browser. Because remember, this is just a URL.
What's a schema?
Schema is the structure.
Like data structure?
Yeah, it's the structure of the
An
JSON.
object.
Got values.
Yeah. So let's actually head there. So I'm going to go to person/1. All right.
Actually, format.
Yeah, this is actually formatted very nicely. Now, if I want to do is what people/schema. That's not formatted nice and neatly. So pro tip, there's a JSON viewer Chrome extension.
Someone showed me at work a long time ago before I knew what any of this meant. There's a website called JSON Pretty Print.
Oh yeah.
If it's on a block like that, it will lay it out like an object.
Yeah, so there's a JSON lint, there's JSON pretty print. JSON viewer is one I've used before. And it'll actually like format your JSON kind of prettier.
Which one's that? JSONviewer.stack.hu?
In the Chrome store.
It's in the Chrome store.
Which one is it specifically? Is it the JSON viewer? Easier. Oh, there we go.
Yep. Nice.
And it formats our JSON in something a bit more readable. So this is that schema endpoint that Chris was asking about. And this is just kind of like, here's the metadata about that endpoint. It can get technical and confusing. So let's head back over to people 1. So this is, hey, I made a GET request to this URL, and I'm getting this back. Ooh, hello.
People is a function,
Yep. You
and
can even do it that way.
and the ID is a parameter.
Yep.
How do you? I mean, what is schema? Is that a function?
Mhm.
So how do you
Differentiate.
in the URL? Yeah, how do you differentiate between the method and the attribute?
So this is using something called REST to define its API standard. REST is a way for us as developers to create APIs that are meaningful. REST is also an acronym. It stands for Representative State Transfer. Yeah, right? Whew, what does that mean? That's nuts. At a high level, what we need to know today is that what REST means is that our URL structure will point to a resource. So what is a resource? In terms of what's going on here and now in week 3, a resource is a JSON object. So anything that points to a unique resource, those parameters go inside of the URL. If it's something that modifies the URL, modifies the resource, that's going to be a URL parameter, which we'll explore in the second half of today's lecture. Does that make sense? For now, at least.
Yeah.
The question is just trying understanding the whole API thing. There's probably hundreds of websites referencing to Swappy.
There's probably a few, yeah.
So if Swappy comes down for any reason, all those websites kind of crash because there's
Yep.
nothing to where to get my reference.
Yeah, so if we build a website on this and this goes down, we're out of luck. Take that for what it is. There are ways to get around that. There are ways to, it's something called caching, where like we cache the data, so we store a temporary copy of it for like a day or two or something like that. But that's one thing to consider when using an external API is what's their availability, what's their uptime. But that's not a decision you should be worried about right now. But good thing that you think about that.
If you touch in the address bar,
Up here?
Yeah.
Not yet. We're going to be using fetch in JavaScript later.
put it in and then it just showed the raw
Yep.
JSON file.
because the browser and fetch do inherently the same thing. The your address bar is making a HTTP GET request to that URL and then displaying the data. Fetch is also making a HTTP request to that URL, but now you can actually you can work on the data itself instead of just seeing it. Does that make sense? So now that we know APIs, we've seen them, we're familiar with them, we have the general concept inside of our heads. It's 10:49. Let's take an 11-minute break. Let's come back and let's actually code something up that explores the Swappy API.